Yeah, man, all I'm saying is a little heads up would have been nice. We go live in 5 minutes. You know this isn't going to stop our investigation, right? Okay. All right, you guys do what you need to do up there. We'll figure something else out. All right. All right, guys. Looks like Elon's making up some excuse for why we can't use the Highbay this week, so we're going to have to figure something else out. I think I might have an idea. Wow. I don't know, Geoff. I think this is the spot. This could be where we do the next show since Elon kicked us out of the Highbay. What do you think? Not bad, right?
I don't know, man. It's been like 3 weeks since I've seen you. Where are you?
I'm actually in Germany. You know, there wasn't a lot of spots available, and apparently on the brochure they said this one was abandoned, so I figured I'd check it out.
Yeah, man. It looks kind of familiar to me.
I know, right? Wait, what do you mean?
Is that Felix's old place?
I mean, it could be. It might be. I think it is. Yeah. All right, Geoff, I know what you're thinking. All we gotta do is change the name. So let's just call it the What Is He Gonna Do About It show, and then we'll be fine.
Welcome to CSI Starbase.
To start off this week's show, I wanted to give a huge shout out to Felix from the What About It channel for letting us borrow his studio after we got kicked out of the CSI Starbase headquarters at the top of the Highbay. Apparently, SpaceX is having some sort of all-hands-on-deck meeting, which clearly we weren't invited to. So with that, thank you again, Felix, and welcome to the United States. This week, we have some important Stage 0 updates as always, and SpaceX is getting closer and closer to the first ever booster static fire test on the orbital launch mount. So we're going to take a look at what all is remaining, and we're going to take a look into a possible major cover-up that's ongoing at Starbase. Before we do that, we're going to share with you guys the results of our investigation into some damage that occurred to Ship 24 a few weeks ago during its first cryo test. We're going to look at exactly what may have happened and what SpaceX is doing to prevent it from occurring again. So in order to explain this, I think we should start out at the moment that I found out about this unfortunate event. Yes, sir. Oh man, I can't wait to show the team the shirt for today's episode. Thank you, RGVAerial. What was that? Oh, nah. Dang. Looks like we got ourselves another investigation. Gonna have to alert the team. Probably not gonna want to wear this one around the office today though. After finally getting a chance to rewind the Lab Padre stream to see what happened, I was literally blown away by what I saw. It's never a good sign to see heat shield tiles get blown off the side of a vehicle that's not even performing a static fire. It takes a lot of force to cause the kind of damage seen here in this image from Starship Gazer after the incident. So what could possibly cause this? Once I watched the video several times over and listened to the audio, I was pretty sure I had a good idea of what happened. After spending several years as a field engineer in the oil and gas industry, I became very familiar with the sound of parting iron and the sound of residual pressure escaping as the system suddenly equalizes to atmospheric pressure. Watching something that is designed to withstand up to 12,000 psi of internal fluid pressure rupture is something you really never forget. After Booster 7's incident, I knew there would be a lot more eyes on the inspections that would be conducted by SpaceX the following day. Between Starship Gazer, Jessica Kirsh, Chief from the What About It channel, and the Lab Padre Rover 2 livestream, I knew if we waited long enough, we would see the damaged pipe getting pulled out. I think it's pretty safe to assume that most of you have already seen what the damaged pipe looked like after it was pulled out of the payload section. It's been covered pretty thoroughly by a lot of other channels. The state of this failed pipe confirmed to me that it was indeed a high-pressure pipe rupture here, but it's pretty difficult to determine what the cause was based on this alone. Initially, I didn't plan to cover this today because I thought there was a lack of evidence to really explain what happened here, and the fact that there was an internal blood vessel pop inside the ship was pretty obvious just off sound alone. With the pipe removed, it was only a matter of time until we saw the replacement inserted. Starship Gazer decided to camp outside the entrance in hopes of catching some shots of it, but after a full day of live streaming, we saw nothing but workers going in and out empty-handed. Right around 6 p.m., Starship Gazer decided to call it a day. On his way out, he happened to catch this footage of SpaceX workers preparing for shift change as well. This is pretty entertaining, so I'm gonna let it roll while I explain this next part. So later in the night, I was just about done wrapping up the script for this week, and I was preparing to go to bed early so I could wake up and start recording fresh in the morning. Before I went to sleep, I got a YouTube notification that said Jessica Kirsh was about to go live. Mind you, it was like 11 p.m. I thought to myself, well damn, that's an odd time to start a stream. I probably would have watched it if not for needing to be up early in the morning, because she has a really weird habit of being in the right place at the right time, so I try not to miss out. Early the next morning, I got woken up by a text at like 3 a.m., and I'm a pretty light sleeper. Usually I would have some choice words for whoever is randomly texting me at that time, but I looked down at my phone with one eye shut and saw it was a message from Jessica Kirsh. When I opened it, there was no words, just a link to her YouTube video from the night before. Needless to say, I was more than confused. I was about to respond, you aight? But I decided to open it and see what she was trying to tell me. Immediately, both eyes popped open. She's still live? Why? And is she stranded out there or something? But then it occurred to me, maybe this might be her way of sending an anonymous tip to CSI Starbase. So I started scrolling through the video and found what she wanted me to see pretty much immediately. Right around the 3-hour and 18-minute mark of her stream, which I have linked in the description, you can see crews lifting an interesting looking pipe back into the Starship. This pipe looks significantly different from the one that was initially removed. You can see that it has 2 U-shaped bends in it, and if you watched my episode from last week, then you probably recognize these as expansion loops. As I mentioned, there are several of them located in the vertical cryotubes running up through the orbital launch tower. So when I saw this happening on Jessica's stream, I thought to myself, wow, I literally just got done talking about this exact same topic, and now it makes a lot more sense what happened in there. Thanks to some help from 3D forensics agent Brian Hansen Space, we can at least create a visual representation to explain the general concept of what kind of failure occurred here. As you can see here, there are 2 sets of pipes that run up to the top of the nose cone and up to the header tanks. The larger ones are for filling and draining of the LOX and CH4 header tanks, while the smaller ones are for tank pressurization. So based on the size of the pipe, it was likely one of the 2 pressurization lines on the left of this diagram. As you can see, when these pipes flex due to drastic temperature changes or even surges in pressure, if the bend becomes too extreme, it can cause it to fail. Just as you would expect if you were holding a straw between your 2 palms and decided to press your hands together. Once this pipe failed, it was likely slapped up against the inner wall of the nose cone, resulting in a large amount of tiles being ejected off of the vehicle. Now let's take a look at the same scenario, except this time with a few expansion joints added in. As you can see, in this configuration, when the same force is applied, the pipes start to act as a spring, which gives it significantly greater ability to resist failure under compression or tension. This is about as close of an explanation as we're going to be able to release, because as of now, Ship 24 has recovered from its surgery and has already successfully completed a cryo test following its rehabilitation. Once again, crisis averted. No need to take it back to the VAB and spend several months making repairs. If you guys tuned into the last CSI Starbase episode, you will remember these large steel panels, which I expected would end up being used as an upgrade to the existing orbital launch mount flame diverters. This is the 3rd time I've mentioned them, but I think we can finally put it to rest after today. As a review, these symmetrical panels came in 2 different shapes, with one of them significantly larger than the other, and of course there was 6 of each type. One thing I noticed in this aerial shot from 2 weeks ago was that after the panels were delivered to the launch site, these tiny tabs were welded onto the ends of the larger panels on the exposed edge that was left unpainted. If you've been following the RGVAerialPhotography live streams every week, then you would have been expecting these to get submerged into the concrete in order to anchor them into the ground more securely. Well, Mauricio was unable to wait for the next flyover to find out whether or not this was going to happen, and neither was I. So instead, he drove all the way out to Starbase just to check whether or not the new launch mount shin guards had been lifted into place yet. Well, sure enough, they were actually in the process of mounting them onto the legs as he was taking this photo. Zooming in, you can see that, well, honestly, they look ugly as hell right now, especially when you compare it to the smooth curves seen on the new launch mount legs in Florida. But let's not rush to judgment too quickly, because I don't think this is their final form yet. Looking at this aerial view, we can see that these panels haven't actually been welded onto the legs yet, so I think it will probably look a lot better once that is complete. I'm also expecting an additional cap to be added onto the top of these, similar to the initial design. With the first ever static fire of a booster on the orbital launch mount rapidly approaching, this is a much welcome upgrade in my opinion. I would estimate that these new flame diverters are roughly 3 to 4 times larger than the originals. As I said before, these are going to be a lot more secure if they're anchored into the concrete. And if you look closely, you can see in this image that they've actually already removed the broken out concrete from the column on the right, and they're still in the process of doing so on the left one. Once they are secured in place, these panels will be submerged at least 10 inches into the ground. If attaching these to the columns using 1-inch welds isn't enough to keep them from being ripped off by the force of 33 engines, well, then hopefully this little touch should do the trick. Alright, there's a question I know is going to appear in the comments, so I'm just going to address it now.
Hey Zach, why do these diverters not travel all the way to the top of the legs?
Well, my only guess is that the simulations that SpaceX has been running in order to determine whether or not that's necessary probably look very similar to this render from Nick Henning, which does a great job of showing the exhaust traveling mostly in the horizontal direction after contacting the ground as it exits from underneath the launch mount. It's probably safe to assume that SpaceX is not expecting the upper portions of the launch mount legs to experience the same conditions as they will near the bottom. With that being said, there is still a very large amount of exposed pipework that I'm hoping will be covered up before the first orbital test flight. That includes every cryogenic and mechanical pipe going up and around the legs. Also, I feel like it's probably not a good idea to leave these gigantic holes open in the outside of the launch table once everything is finalized. Not unless they want to have to remove bird nests from it every year after mating season. This is where a skirt that encloses the entire walkway would come in handy. That would also protect all of the equipment that's mounted on the outer wall of the launch deck. I still don't think this little umbrella we got going on up top is enough to protect this area. At the very least, I expect these insulated cryo tubes underneath the launch mount will be covered up on all 3 sides where they're currently exposed. I don't think that's too unreasonable of an expectation, right? To some degree, this process has already started though, so let's look into that. Now, this might not be news to some of you, but 2 weeks ago, this very large steel cover for the cryogenic flex hoses on the exterior of the OLM was delivered to the launch complex and lifted into place as shown here by Ezekiel Overstreet last week on Twitter. Ezekiel is a new photographer on the scenes and has been capturing some pretty great images, and definitely worth a follow if you haven't already. Anyways, due to the awkward shape of this piece, once it was lifted to the correct height, SpaceX workers had to use ratchet straps in order to pull the bottom of the shield into position. Once it was fully seated, it was looking pretty dang sharp. It's kind of hard for me to explain to y'all how excited I was for this milestone, but just know that Stage 0 Zach has been waiting for this for a long time. Ever since this piece arrived, I've been examining RGV aerial flyover photos looking for signs of additional paneling that may come later. My guess is that soon we will see more panels for the legs and exterior walking platform fabricated out of these large piles of rectangular sheet metal sitting outside of the ground fabrication building. But so far, that is just speculation. My excitement didn't last long, however, because the very next morning, I got word from our European CSI Starbase agents that while those of us on this side of the pond were PTFO for the night, the cover had been removed from the launch mount and set back onto the ground. You know, unfortunately, none of our agents were surprised by this news. In fact, we were actually impressed that it was installed in the first place because we assumed it may have taken a little damage to the mounting surface after this little event when it face planted onto the deck of this trailer. Now, when things like this happen, it's usually due to operator error, but in his defense, this driver was reversing just about as slow as the truck is capable of. I blame it on the wind, honestly. Don't worry though, as far as we could tell, no one was injured in this event. But what about the steel cover? Would it be damaged enough by that fall to cause it to no longer fit correctly? I mean, it is a possibility, but I wasn't sold on that, and I figured there might actually be something else going on here. After a close inspection, some of our top forensic analysts were able to identify a change to the rear support frame of the BQD cover that helps us better understand why the flex hose shield was removed. When we compare this first image by RGV ground drill from 3 weeks ago to this one taken by Starship Gazer after it was taken back off the night before, you can see this new addition to the rear frame, which made it easier to spot thanks to the insane amount of rust on this metal panel. Initially, I thought that the mounting surface had been severed from the blast shield using a plasma cutter, but looking from the aerial view, we can see that these were in fact additional frames next to the shield which previously went unnoticed. When we look at this side profile view taken by Chief from the What About It channel, you can see gaps between the rusted plate and the black painted cover. These are referred to as tack welds. They are small temporary welds that hold parts together for the final welding process.
Typically, when you're welding two surfaces together, you have to first come up with some kind of jig to align the parts perfectly and hold them in place until there are a sufficient amount of tack welds for it to support itself without the jig. In this case, the massive cryogenic flex hose shield was the jig of choice. But as a mechanical engineer, I also think it's pretty brilliant. I mean, why take the time to break out fancy-ass laser scanning total stations and other measuring tools when you can just use the structure it's intended to interface with as the alignment tool instead? I'm probably going to have to try this myself at some point. The next house I build, I'm probably going to start by suspending a door in midair and then building the framework around it. Probably going to save myself a ton of time, honestly. With the cover back on the ground, SpaceX crews got busy right away performing the final welds to this frame pretty much all day long and into the night, as shown here by Starship Gazer. Once this is finished, the cover will be remounted using these holes arranged around the outer edge. Attaching this shield using very large bolts with some equally huge nuts will allow it to be easily removable in the event that any of these super heavy sized flex hoses ever need to be swapped out in the future.
All right, guys, look. I don't know if SpaceX thinks we're stupid, but this is clearly part of some kind of larger cover-up. And I don't think it's gonna end there. So if I see any more signs that SpaceX is gonna throw some more clothes on this naked launch mount, I promise I'm gonna be the first ones to let you guys know. And if you don't wanna miss out on that update, make sure you hit that alert icon at the bottom of the screen.
Moving on from the cosmetic upgrades, there was some additional testing done on the launch mount this week that went largely unnoticed due to the fact that it's near impossible to see from the ground unless you were standing within about 50 feet from the structure, or if you happen to catch this moment from Starship Gazer's live stream. This is actually the second time we have witnessed this mysterious testing device being lifted out of the orbital launch mount, but without seeing what it looks like while it's in use, it's pretty hard to determine what its true purpose is. Luckily, Mauricio from RGV Aerial happened to capture the perfect shot of it before the testing had concluded. Looking closely, we can see 20 cables extending from the device being suspended in the center of the launch deck. Each of these cables attach somewhere above and behind the 20 clamps used to secure the super heavy booster in place. It appears that the cables actually contact the leading edge of the clamps, but it's very hard to tell. Assuming this is true, the CSI Starbase team has come up with a possible explanation of what we are seeing here. The first theory is that SpaceX is using this device to try to more accurately level the 20 different mounting points so that when the booster is sitting on top, it's perfectly vertical. Basically, the goal would be to raise or lower each of the hold-down arms one at a time until they're just barely touching the cable, and then locking that position in so it always returns to the same exact spot. But is this even necessary? I mean, surely it's already level, right? Well, if we look back to the first full stack test, there's something here that's a bit hard to notice, but still very apparent once you see it. In this footage from Lab Padre, we can see that without the chopsticks, stabilization claw, or a crane attached to provide support, the booster actually leans a little bit more to one side, and it's leaning in the direction of the launch tower. This issue clearly wasn't addressed after the first stacking because you can see it again during the second full stack test after the booster stabilization claws had been removed. Without the claw to push the booster up into position, SpaceX instead used the chopsticks to tilt the ship a few degrees to one side until it matched the lean of the booster. This really only matters during the last few seconds before launch, as the stabilization and ship quick disconnect arm detach from the vehicle and move out of the way from the controlled explosion that's about to occur. When the claw releases, the fully loaded booster is going to want to immediately sway to one side. Theoretically, this should result in a massive amount of torque on the hold-down clamps, which is probably something they aren't really designed for. The thing is, this full stack test was a very long time ago, and SpaceX is most definitely aware of the problem, so maybe they've already fixed it by now. The second working theory is related to the clamp mechanism itself. To explain this, we're going to have to review how these clamps actually work. In this simulation from SpaceX 3D Eccentric, we can see what the hold-down clamps look like as they fold out from the table. You can see where the rim of the engine skirt sits in the middle of each of those clamp bases. In this render by Christian Debney, posted to Twitter just a few days ago, you can see the outer rim of the booster skirt, which is located in between each of the engine bells. This is the surface that sits on top of the hold-down arm. Just above the rim, there's a pretty large indentation, and looking at it from this angle, you can probably even visualize where you would place your hands and fingers on this thing if you were to reach up and try to pull the booster towards you. In this insane close-up from RGV ground drill, we can see the mechanism that takes the place of your hands in this analogy. Looking at it from the side, it's easy to see how this rotates forward onto the rim of the booster and locks it into place. So now that you understand this, Try to picture the super heavy booster with Starship on top as it fires all 33 of its Raptor 2s at T-0. It's safe to assume that the clamps will remain engaged until all engines are lit and have begun to throttle up. Before the booster lifts itself off the pad, the clamps will have, probably just a few milliseconds to get the fuck out of the way before they damage the engine skirt or something way, way worse. I don't think it's possible to achieve absolute perfect timing, but the release of these clamps needs to probably be synchronized with a ridiculously low variance in the moment of release between all 20 positions. That variance is probably not observable by the human eye. How are you going to look at all 20 of them at the same time? SpaceX does have cameras positioned all around the launch mount, pointed at each of the 20 clamps and 20 Raptor quick disconnects, which might be able to do the job, but I don't think it would be accurate enough. Plus, the purpose of these cameras is actually to allow for automation of the chopsticks without humans standing on the launch mount. By the way, these cameras were not fully installed until after the second full stack test, so that is likely one of the many reasons that they haven't used the chopsticks yet to stack a booster. So one way to do this kind of calibration could be to manually retract each clamp about 30% so that the front of the clamp is less than a millimeter away from the tensioned cable. Once everything is in position, you hit the release button for the clamps, and as they individually make contact with the cables, 20 separate signals will be sent back to the monitoring device. Using that data, you can then measure the variance and make adjustments as needed. It wasn't until after we came up with this theory that we noticed there's actually a very large data cable coming out of the top of the device, which is likely feeding information to a collection system located somewhere on the launch mount. If you look around the edges of this device, it's pretty hard to see with great detail, but I can only assume that these cables are attached to a strain gauge or some sort of limit switch designed for this task. So, with the orbital launch mount getting closer to its final form every day, we should be ready for a static fire relatively soon. Now that's all fine and dandy, but there's still more work to do before Stage 0 is ready for Starship's debut orbital flight. I've mentioned a few systems in the tower that haven't been completed yet in my last episode, but some of you may have noticed that I've purposely avoided talking about several features of the orbital launch tower since our agency made the decision to go public with these investigations. Now, why would I do that? Well, the reason is simple. Just like Mechazilla, I'm still recovering from that public mutilation that occurred a few months back. I'm referring to the moment that SpaceX removed the extendable SQD umbilical arm, which is responsible for loading fuel onto the second stage vehicle. It took me a while to get over this. I really felt it in my soul when it happened. Honestly, sometimes I get so absorbed in the Stage 0 development process that I completely ignore changes that are happening with the vehicle itself. Well, fortunately for me, the staff here at CSI Starbase includes several members of the Ring Watchers team, and they were able to get me up to speed and remind me that this is a necessary change in order to adjust for the new QD panel positioning on the latest generation of Starships. While this makes sense, I was still a bit sad because I've been following this particular Mechazilla appendage closer than anything else ever since the day I watched the main structure of the original SQD arm arrive at site at Starbase on my second trip to Boca Chica. I remember it like it was yesterday, pulling over on the side of the road with Starship gazers so we could get some photos of the new SpaceX LR-11000 crane which had just arrived from Germany. As he and I were walking back to the car, a pickup truck with an odd-looking structure on the back of it drove by. It's still kind of crazy to me that I knew what it was immediately, but at the time, we were on the lookout pretty much every single day for something that resembles an extendable quick disconnect for the Starship after the massive GSE arm was installed onto the tower. I sent this to Owa from SpaceX 3D Eccentric so he could begin adding it into his model before everyone else figured out what it was. Fast forwarding to the present day, a few weeks ago we witnessed the first new pieces of the SQD begin to be installed into the tower. I knew this was going to be a pretty significant design change because the original QD didn't require anywhere near this amount of support structure. Given that the QD on the new Starship is mounted a bit higher, there is now a ladder which looks kind of like a chair from this angle, which will allow for easy access to the SQD connection for ground personnel. So a few days after these parts were installed, the new umbilical arm finally made its way to site and was lifted into place shortly thereafter. It's been about a month since that day, and every time Starship Gazer or Jessica Kirsh have gone live over the last 4 weeks, I've been watching closely to see if they would show signs that this system is back to being operational again before we see SIP 24 and Booster 7 at the pad for the first time together. Well, on this particular occasion, I joined the live stream a bit late, so I had to spend some time reviewing the footage at 10x speed in order to get caught up. I'm almost grateful I was late for my night shift investigation this evening, because had I not been watching this at 10,000% speed, I probably wouldn't have noticed the slight movement from the SQD umbilical as I was scrubbing through the footage. The moment I noticed, I damn near sprinted upstairs to my computer to type into the chat, Hold up! Did anyone else notice the SQD being tested a few minutes ago? Starship Gazer was on it immediately, and when he turned back to the right spot a few seconds later, sure enough, we were able to witness the first de-erection test of this system since it was stripped out and upgraded. This was the same live stream where we witnessed the SpaceX crews welding on the black flex hose shield we discussed earlier in the episode. So it was a busy night. Honestly, we were so excited just to see it retract this one time that we almost forgot that this is most likely just an initial test at super slow speed just to make sure there are no kinks in the hoses. I texted Gazer and told him to be on the lookout in case they decided to do it again. So with that being said, check out this time lapse of the function testing that went on later that evening. You can see that each time it's extended and retracted, it's a bit faster the next time. We didn't get to see it at full speed, but that's fine because this footage is rare enough as it is already. I can't wait for the next full stack test of the Starship and Super Heavy booster. It's looking like this tower is just about ready for action. Wow, as I was recording this, I realized I skipped over a pretty gigantic elephant in the room. We are still missing the booster stabilization claws. These were removed along with the original SQD umbilical arm and sat on the ground near the launch tower for several weeks before they were taken to the Sanchez site and thrown away like garbage. At this point, I can't think of a reason for removing these, as there haven't been any changes to the lifting point on the new generation of Super Heavy boosters. I imagine the replacement for this will arrive within the next few weeks, and when it does, you can bet the CSI Starbase team will be all over it. Our investigations don't end until we are able to provide you with an answer for why it was necessary for SpaceX to remove the claw, which in my opinion, was one of the coolest features of the entire orbital launch tower. Alright guys, that's all we have time for today, but before we go, I want to show you guys a little preview of something I've been working on for the last 4 episodes that really keeps getting pushed back due to all these new developments that keep happening out at Starbase. As a commentator for the Lab Hydra channel and co-host of the RGVAerial Starbase weekly review live streams, I get asked a lot of questions about the orbital tank farm, especially during testing events. It seems to me like a lot of you might like to get a better understanding of how all these systems work. I mean, even the everyday astronaut asked Elon Musk about how the detank process works, but unfortunately, he didn't get an answer either. So, I'd like to hear from you all in the comments, and let me know if a full explanation of the orbital tank farm is something you might be interested in. And this isn't a rhetorical question either, because this is going to require a lot of effort from the CSI Starbase 3D forensics team to simulate all of these systems. And seriously, if you guys haven't followed Lolamatic and Too Legit to Quit on Twitter already, then make sure you do, because this isn't the only project they have in the works. I can't wait to explain all these systems because I think it's really helpful for people to be able to understand what they're seeing during various stages of the testing events so they can get a better appreciation for the amazing engineering work that goes into this. I mean, let's take this orbital GSE bunker as a quick little example. Did you know that these canisters on the roof hold gaseous methane, nitrogen, helium, and oxygen at pressures ranging from 3 to 6,000 psi? I mean, that's crazy, right? What could they possibly need that kind of pressure for? Well, with the help of Seabass Productions, we should be able to get down to the bottom of that as well too, and explain the step-by-step process for successfully igniting 33 Raptor engines and getting the Starship and Super Heavy booster off of the pad and as far away from the launch complex as possible, where it's free to do whatever it wants at that point. It could make it all the way to orbit, or it could blow up during max Q for all I care. As long as Stage 0 is safe, I'm good. Thank you guys for joining us for this week's CSI Starbase Deep Dive Investigation. I want to give a huge shout out to those of you who have supported us so far on Patreon. It has gone a long way into helping us continue to improve the quality of these episodes every single week. If you guys would like to become a supporter as well, then you can find the Patreon link in the description. For those of you who are looking for even more updates, don't forget to follow CSI Starbase on Twitter, where I tend to post a lot of things that I don't have time to cover in these episodes. All right, guys, see you next week. We're out.